Hello students, this is Mr. Wilsey, and in this video we're going to be looking at the Algebra 1 objective on multiplying binomials. Now let's take a look at this first problem here. We have a rectangle, and the lengths of the sides are 2x plus 3 down here, and 3x here. X just represents some number. We don't know what the number is, but it doesn't matter, because the whole idea of this first problem here is to learn how to multiply and add the lengths of these two sides to find the perimeter and the area. So let's first of all look at part A. What is the perimeter of this rectangle in terms of x? Now remember that perimeter is the total length of all the sides of the shape. So this means that we're going to have to recognize that the length of that side up here is also 2x plus 3, and the length of this side over here is also 3x. So in order to find the total length of all the sides, all we have to do is add these together. Well, let's see, we have a 2x and a 3x, and then a 2x here, and then a 3x here. So 2 plus 3 plus 2 plus 3 is 10. So we know that part of the perimeter is going to be 10x. Now we have a 3 here and a 3 here. So add those together and we get plus 6. This skill, we just added all of these polynomials together, is exactly what we did up here. Now, in order to find the area of the rectangle, we're going to have to multiply. Remember that the area of a rectangle is the length times the width. So we're going to multiply the two different dimensions of this rectangle. So we're going to take, let's say, 2x plus 3 times 3x. But the key here is that we need to wrap 2x plus 3 in parentheses to indicate that the 3x needs to multiply the 3 and the 2x. So let's simplify this a little bit further. A equals, let's see, 2 times 3 is 6. X times x is x squared, and then 3 times 3x is just 9x. So the area of this shape in terms of, the area of the shape in terms of x is just 6x squared plus 9x. Alright, let's move on to the next set of problems. Use any method, including double distribute, FOIL, or the box method to multiply these binomials. Now, I'm just going to go back and forth between these different methods here. So, let's see here. X plus 2 in parentheses times x plus 6 in parentheses. I'm going to use method 1, double distribute, to multiply these binomials. So, double distribute says I'm going to take the whole first one, and I'm going to distribute that to the x and to the 6. So that means the next line is going to be x plus 2 times x plus x plus 2, still in parentheses, times 6. And then I'm going to distribute twice on this next line. I'm going to distribute the x to the x and the x to the 2. So that will be x squared. Remember that we are multiplying here. And then x times 2 is 2x. Alright, let's distribute over here now. 6 times x and 6 times 2. So 6 times x is just 6x. 6 times 2 is just 12. Now, just like in the very first objective in this quiz, we're going to need to combine like terms. We have an x. We have an x. So 2 plus 6 is 8 times that x, and then everything else stays the same. So that is the simplified form of that binomial, of that pair of multiplied binomials. Alright, let's take a look at the next one. 2n minus 9 in parentheses times n plus 6 in parentheses. Now I'm going to use, let's say, FOIL for this one. Let me show you how FOIL works. F-O-I-L. The F tells you to multiply the first two. So 2n times n, right? The first terms in both binomials. 2n times n is 2n squared. The O tells you to multiply the outside terms. 2n times 6 is 12n, plus 12n. I tells you to multiply the inside terms. Negative 9 times n is negative 9n. And then L tells you to multiply the last two terms. Negative 9 times 6 is negative 54. Now, just like in the last problem, we need to combine like terms. There's an n term and an n term here. So 12 minus 9 is 3 multiplied by that n, and then everything else stays the same. So that's all there is to it. Now, I chose to use the FOIL method for this one, although you can use any three of these methods, whichever one you like the most. Now, let's look at the next one. 2y plus 3, the whole quantity squared. Now, in order to simplify this one, we need to recognize that 2y plus 3, the quantity squared, is the same thing as 2y plus 3 in parentheses times itself. And from here, it's clear to see that we can use any method to multiply these. So I'm going to use FOIL again. So F-O-I-L. Multiply the first two terms. 2y times 2y is 4y squared. Outside terms are 2y times 3 is 6y. Inside terms, 3 times 2y is, again, 6y. And then L, multiply the last terms, 3 times 3 is 9. Finally, combine these like terms. There's two terms with y in it, so this is going to be 4y squared plus 6, 12y plus 9. And that's it. We are simplified. Now, the next problem here, number 7, this is a little bit different than the ones that we've just done. We can't use double distribute or FOIL or box method. We're just distributing in this case. We're just distributing the old-fashioned way, right? There's no double distribute, nothing fancy like that. All we need to do is take this, multiply it by the first term, and the second term, and the third term. Okay, so all we're doing is distributing here. So let's see here. 4y squared times 2y cubed. Well, look at the numbers out front. 4 times 2 is 8. And then we know we're going to have a y in there. The question is, what is the exponent on the y? Well, remember, we are multiplying y squared times y cubed. When you multiply powers, you add the exponents. So 2 plus 3 will give 5. So 8y to the 5th power plus 4 times 3 is 12, and then y squared times y is y cubed. Notice we just added the exponents. There's an invisible 1 here. 2 plus 1 gives 3. And then finally, 4 times negative 7 is negative 28. And there is no y here, so we just keep that y squared. And that's it. That's all there is to it for number 7. Alright, now let's look at number 8. Number 8 is a little bit scarier. In fact, this should have been red if I had a color printer. Red means this is a little bit more of a difficult one. Now, I'm going to use the box method here. We can use the box method to multiply these. This is a binomial. This is a trinomial. Now, we can't use the FOIL method here because there's too many terms. We can only use FOIL for binomials that are multiplied together. So let's set up the box method here. Box. Okay, let's see if that's enough. Now I'm not going to use this up here. I never do. Let's see. I want to put 2k right here and then negative 5 down here. Now across the top I'm going to have 3k squared. I'm going to have a k, and then I'm going to have a negative 1. Now, in these middle boxes, we are going to multiply. So 3k squared times 2k goes here. Well, 3 times 2 is 6. K squared times k is k cubed. Here, k times 2k is 2k squared. And then here, this is going to be negative 2k. Now down in this box, we're going to take 3k squared times negative 5. That's going to be negative 15k squared. Down here, this is going to be k times negative 5. That's negative 5k. And then down here, negative 1 times negative 5 is going to be positive 5. Now, here we have all of the pieces of our final answer. Basically, we have something that looks like this. We have all the pieces. We have all the pieces. We have all the pieces. Now we just need to combine like terms. So let's see here. There's no other k cubed term, so we know that 6k cubed can't combine with anything. So it's going to be in our final simplified expression. How about k squared terms? Let's see, there's a k squared term here and a k squared term here. So we're going to take 2 minus 15. Now, remember, we are combining like terms. That means we're going to add or subtract. So 2 minus 15 is negative 13, and that's going to multiply k squared. Now we have a k term here and a k term here. So negative 2 minus 5 is negative 7k. And then finally we have a 5. That can't combine with anything, so it's going to be stuck out here. And that's it. That is our final simplified expression. And that is all there is to it, to this objective. Again, there were a couple different methods that I used, but in general, any method will work, except of course FOIL will only work for binomials that are multiplied together.